Hello, this is Ruth Shepherdson, and today's lesson is on the basics of electricity. This lesson is intended for applied ag technology classes as well as introductory principles of ag mechanics. To use electricity, you first must understand a couple basic things. The definition of electricity is a form of energy. However, this energy is very important to us in society right now because it can produce light, heat, magnetism, or chemical changes. We use electricity in almost everyday life in the United States, and so we need to have a lot of measurements of electricity in order to build the circuits to use it, as well as figure out the monetary value of it. The first term you need to know is ampere, which some people might call amp for short. Ampere is defined as the rate of electrical flow. So it's the amount of electricity flowing through. The second term is voltage. Voltage is a measure of electrical pressure. It is oftentimes called volts, or it might also be referred to as EMF. When you combine that flow and power or pressure of electricity, you come up with a term called watts or watt or wattage. A watt refers to the amount of power that is derived from a device or the rate of doing work. If you're walking through the grocery store, you might see a label, something that says like 100 amp light bulb, or you might look on the tag of your blow dryer and see that it's a 1500 watt blow dryer. Now, electricity is sold by the kilowatt hour. So local electrical cooperatives and electric companies then measure how many watts you use in your household, and you are billed by the kilowatt, which is equal to 1,000 watts. In order for us to utilize electricity, you must also understand resistance. Resistance is the tendency of any material to prevent that electrical flow. So later in this class, you'll learn more about how electricity always flows in a circuit, and some things make that flow go well, and some things do not. Resistance is measured in ohms, and it relates to Ohm's law. The two basic terms you need to be familiar with are insulator and conductor. Insulators are things that provide a great amount of resistance and oftentimes will not allow the electricity to continue on in that circuit. Conductors, however, are a substance that allow for the flow of electricity and encourage it to follow a certain path. We know that copper and aluminum are very common conductors. Gold is also a good conductor, but there are things all around us like water that are also good conductors. You'll see the address of a YouTube video here. There's a lot of other resources on the internet that can kind of teach you about resistance and that relationship between volts, amps, and resistance. We see a little diagram in the bottom right-hand corner of this slide that tells us how we can understand the relationships of the current or the amperage, the voltage, and the resistance. And knowing how that triangle works and using it in a mathematical way is a pretty integral part into measuring electricity and, more importantly, measuring resistance. For beginners, I like to use something that was taught to me as being called the West Virginia formula. And it was called that because WVA are similar to how they indicate West Virginia as an abbreviation. That's the word. And so I've always remembered it as that. But basically, we can form a similar triangle to the one you just saw about resistance, and you can know that watts equals volts times amps. And so to figure out how much work that can be done in a circuit, it's equal to the voltage times the amps. Another analogy that oftentimes helps students understand this relationship, or this West Virginia analogy, if you will, is the idea of washing your car. So if you have a large hose and you're going to wash your car, then washing the car would be the work you're doing. or the wattage. You can do it faster if you have a large hose with a lot of pressure. And so if you analyze that hose, the flow of the water through the hose is your amperage, and the pressure behind that water is your voltage. And if you have high pressure and high amperage, you can wash the car very quickly, which would indicate a lot of wattage. The other great thing about the West Virginia formula, or watts equals volts times amps, is that you can, if you have two of the numbers, you can always find the third one. And so I fully intend for you to pause this video and try these as we go through the mathematical parts. But the basic idea is illustrated here. If you knew that the voltage to a light bulb was 120 amps and the wattage that that bulb pulled was 60 watts, you could easily figure out the current, which is the amps. So we know that 60 watts equals 120 volts times the amps. We don't know the amps, so we indicate it with an X. And then when we solve for X, we come up with 0.5 amps. Here's a couple opportunities for you to practice your skills. And I tried to come up and brainstorm some realistic ways you might use this. Let's say you need to know how many 40-watt light bulbs you can put on a certain circuit. You know the circuit is 120 volts at 50 amps. Well, you would have to figure out how many watts, or what your total wattage is, and then do the math problem about that. You could do the same thing, figuring out which items need to be on a 30, which things can be fit on a 30 amp circuit there below. So take some time to pause and try those out, discuss with the people you're working with. One of the great things about an equation like this is that you can manipulate it in multiple ways. If you're not familiar with that mathematically, these next 3 slides kind of show you ways that you might solve for each of those. So solving for watts, you would multiply the volts times the amps, and there's a sample question for you to work through. If you wanted to calculate the amps, you would just maneuver that equation differently. And finally, you would want to calculate the voltage. In terms of today's assignment, I would like for you to try these as a group and make sure you understand how it works. And then you will have a couple assignments that actually give you math problems that you need to finish. Just as a quick review, we need to talk about conductors and insulators. Conductors, again, allow electricity to flow through it. We talked about this earlier, but be aware that water is a conductor. That helps with some electrical safety if you know and understand that. And then also metal does. And so that bit of knowledge then applies to your welding scenarios. Insulators do not allow electricity through it. We use this knowledge to keep us safe in a variety of ways, like linemen using rubber boots, like plastic, helping things, and stuff like that. So conductors versus insulators is an important thing to know. For the lab part of today's assignment, you're going to use a multimeter. There's a picture of a multimeter here, but you should know they range anywhere from the $8 cheap ones you might find to $150 or $200 digital ones. They are measuring instruments. You can typically measure volts, amps, and ohms on them. And so you will first select which you want to measure. You'll be intentional about your connections, and then you'll be able to read some things. So in the kits that we have there, you're going to each be assigned a multimeter, and I would like for you to turn that on and kind of experiment with that. You're going to start by testing a 9-volt battery to figure out your amperage and your voltage. And so the best way for you to do this is actually to pause the video at this point, leave these instructions on the sheet, or have your substitute teacher read through them, and then go ahead and see if you can test a battery or several batteries. If the sub is comfortable with it, it's also kind of a cool experience to go ahead and build a simple circuit and then use your multimeter to test what that voltage is all throughout the circuit. And finally, these are the resources used to make this lesson. So enjoy and experiment a little bit and learn from the scenarios. Have a good day.